Hello, I am Professor Sachin Sambhaji Patil. I welcome to all of you for this session. So in this session, we are going to see 80386 microprocessor, its basics, fundamentals. Okay. So as we see the evolution of microprocessor, if you see the evolution, how the evolution of microprocessor has been taking place. So in this, if you see here, the initially was there is evolution of processor. So in this, initially there were the processor which means first developed, that is a 4004 processor, and later on the processor evolution has been taking place. So if you see here the 4-bit processor, so for this 4-bit processor is having the Intel 4004 processor, and for this processor can perform operation on 4-bit. So what is a 4-bit processor? जो first processor develop किया था वो 4-bit था, and that 4-bit processor was able to perform operation on 4-bit. Okay, so as we know what is 4-bit, 0000 to 1111. Okay, then later on the processor, if you see the evolution of processor from beginning, so you can see the processor, first column processor, then clock speed, then data bus width, then address bus width, and special features. So initially the processor, so that is the 4004, it is developed first. Okay, for this processor it has the clock frequency, that is a 740 kilohertz, 740 into 10 to 3 hertz. It means that 740 kilohertz, that is that much clock frequency signal was generating, and the execution time was, we know that the relationship between the execution time and frequency. So if you see here this relationship, this execution time and frequency, so f is inversely proportional to the time. T is a capital. Okay, T is the execution time of the instruction. So as frequency increases, execution time will be decreases. If execution time will be decreased, the performance of processor will be increased. So in the evolution of processor, important thing is that as the execution time, to decrease the execution time of the instruction, execution time of the program to decrease, we need to increase the frequency. Okay, so that's why in evolution of processor, every time the frequency of the crystal oscillator, clock frequency, it is increased, and who is generating clock signal, which component is generating clock signal, that is a crystal oscillator. So in human being, as we know, without heart we cannot work. Okay, so heart is generating the heartbeats. In similar way, in microprocessor, there is a crystal oscillator is one of the component. That component is generating the clock pulses, clock signal, and with respect to the clock pulses, clock signal, execution of instruction, execution of program will be take place. Okay, so crystal oscillator, it is a component in microprocessor for generation of clock pulses, and in human being, heart is there for generation of heartbeat. Without heartbeat we cannot work. Okay, like this. Okay, so heartbeat is nothing but clock pulses, and heart is, it's nothing but crystal oscillator component. Okay, so as frequency increases, execution time will be decreased, the performance of processor will be increased, the performance of processor will be increased. So if you see f is equal to 1 upon t, or t is equal to 1 upon f. So if you assume this is the clock signal, we can see here this clock signal is having rising edge, high pulse, falling edge, low pulse, again rising edge. So this much interval, again this rising edge, when this edge again this edge is coming after some time. So this is the time interval, the time taken by signal to complete one cycle. This cycle is again repeating, again the cycle is repeating. So this is called as one cycle. What is one cycle? That is the time taken by signal to complete one cycle. It is called as capital T. Okay, and capital T is equal to 1 upon F. F is a frequency. Suppose if I assume the frequency 1 kilohertz, any crystal oscillator is having the frequency of 1 kilohertz. So 1 kilohertz, so T is equal to 1 upon F, so 1000, 1 upon 1000, so 1 into 10 raised to minus 3 second. So T is equal to 1 millisecond. Capital T is equal to 1 millisecond. Okay, so it means that to complete one cycle, it is taking the time of 1 millisecond. To complete one cycle, it is taking time of 1 millisecond, and that 1 millisecond means in this way how many cycles will be there in 1 second? 1 second, how many cycles will be there? That is a 1000 cycles. So 1000 multiply 1 millisecond. So 1000 multiply 1 millisecond. So 1 into 10 raised to minus 3. Okay. So 1000 divided by 1000, that is 1 second. So this 1 is nothing but in numerator 1. In numerator 1 is nothing but 1 second. So T multiply F is equal to 1 second. Okay. So this is the we are getting, and this is the 12 megahertz. Suppose we take example of 12 megahertz crystal oscillator. Emit 12 into 10 raised to 6 hertz. And what will be execution time? Capital T is equal to 1 upon F. So 1 upon 12 megahertz. So when this megahertz goes in numerator, it becomes 10 raised to 6, becomes 10 raised to minus 6, means microsecond. So execution time will be in microsecond. So as we increase the crystal oscillator frequency, the execution time of the program will be decreased. If execution time will be decreased, performance of processor will be increased. Okay. So this is the important in the term of crystal oscillator. Okay. So this is important. So if you see here, next one, the 4040, it is next processor which is having data bus of 4 bit, address bus of again 4 bit, and this is the interrupt is introduced here. The next is 8008 processor came, 8-bit data bus, 8-bit address bus, then 8080 2 megahertz clock speed, that's a crystal oscillator frequency, then 8-bit of data bus, 16-bit of address bus. So 8-bit is nothing but 1 byte, and 16-bit is nothing but 2 byte. Okay. So next one is that 8085. This processor is having 3 megahertz, 5 megahertz crystal oscillator frequency, and T is equal to 1 upon F. So I am getting, this is the microsecond, the execution time of the program. So as the frequency increases, execution time will be decreased. Then 8-bit of data bus, 16-bit of address bus. Then special features are that serial communication, it introduced in the 8085 processor. Then 8086 processor, there is one more feature added here, multi-bus capability, multi-processing, configuration and pipelining. Okay, so that is a crystal oscillator frequency 5, 8 or 10 megahertz, data bus 16-bit and 20-bit of address bus. So what is the concept of data bus and address bus? That you have to understand. What is the concept of data bus? What is the concept of address bus? Okay, that you have to understand. So if you see here the concept of here data bus, so you can see here this is the processor. If you see here, this notch is indicating this processor. Okay, if it is IC, it is an integrated circuit. Okay, so pin numbers are starting from anti-clockwise direction from this notch. So this pin number 1 is here, pin number 1, 2, 3, 4, 5, 6, okay, up to this, okay, and up 20, then 21, 22, 23, here is 40. So pin number 40, it is the power supply is required, that is plus 5 volt, pin number 20, it is for ground. And for the processor, if I am saying it is having suppose this 8086 having address lines, okay, 20 address lines. So these address lines are unidirectional. And this D is a data bus. So data bus are bidirectional. Data bus are bidirectional, and these are 16. So in the both directions we can communicate. So we can send data, means write operation, or we can receive data from peripheral or memory to the processor. It is a read operation. So read and write are the control signals. Okay, and in the processor, important thing is that is a crystal oscillator for generation of clock pulses, for clock signal. Okay, as you know that in a human being, without food we cannot get energy. So in the processor also there is a, to get energy, to make it on, to make it enable IC, we need a power supply, that is a plus 5 volt, and this is a grounded. Okay, and address bus, the depends upon the size of address bus. Okay, we can decide the memory size. So 2 raised to number of address lines. Suppose 20 address lines, this processor having 20 address lines, 2 raised to 20. So that much bytes of information we can store in this memory. Okay, divided by 1024, I am getting the 1024 kilobyte, that is a 1 megabyte. So 1 megabyte, that much memory can access by the 8086 microprocessor. Okay, along with this processor having the 16-bit data lines. These are the bidirectional, means this processor can send data, means write operation. Okay, this processor can read data, this read operation via this data bus. So based on the data bus, address bus is deciding size of ALU, address bus is deciding size of memory. Address bus is deciding size of memory, and data bus is deciding size of ALU. Remember this, data bus is deciding size of ALU, arithmetic logic unit, and size of register. So what is the size of the register? Register is how many bit? It depends upon the data bus. If the data bus is 16, means register will be also 16 bit. ALU size also 16 bit. Size of memory depends upon the address bus. So 2 is to number of address lines, that is size of memory. So there are two units are existing in 8086 microprocessor. That is, the first is BIU, bus interface unit. Second is EU, execution unit. So when fetching means taking data. So fetching of data from memory or IO take place, it goes to BIU. So BIU consists of address bus, data bus. It goes to execution unit. Execution unit consists of ALU, arithmetic logic unit, and after doing operation, that data will be sent back to the BIU, and that BIU will be sent data to the memory or IO input output. Okay, so in this way there is a working of this 8086 will be taking place. 8086 having the only two functional blocks, only two units are there, BIU, bus interface unit, and second is EU, that is the execution unit. Okay, but in 8086 there is a number of units increased. 8086 consists of the units, that is a bus interface unit, okay, code free page unit, instruction decode unit, execution unit, segmentation unit, and paging unit. Okay, so memory management is not possible in 8086. Memory management is possible here, and virtual mode is available in 8086. So in our syllabus we have to study the 8086. This processor is having 32 bit of data bus. So registers will be 32 bit and ALU will also 32 bit. Address bus 32 bit means size of memory also 32. 2 raised to 32 means 4 gigabyte. 4 gigabyte is the size of memory can access. So 2 raised to 32, 4 gigabyte. And these are the crystal oscillator frequency 16, 20, 25, 33 megahertz. So 80186, this is the having these features: on chip timer, DMA direct memory access control, interrupt controller. 80286 having the memory protection, support multitasking, and 80486 is having level 1 cache memory on chip. So these are the important that's evolution of processor, how it is be taking place in the case of 80386. Okay, how it is evolution has been taking place. Initially was 4004 4-bit processor, then 40, then 8008. In this way there is a 1